My name is Aleah Sommers and I'm a PhD student in the Department of Civil, Environmental and Architectural Engineering at CU-Boulder. My research focuses on understanding the effects of liquid meltwater on the Greenland ice sheet. Now everybody thinks of the ice sheets contributing to sea level rise. They're melting away, they're flowing into the ocean. But what a lot of people don't realize is that there's this complex network of inner channels and conduits both within the ice and the bed. And so it's not entirely straightforward how much of the water that melts every year actually goes into the ocean. My research approaches this problem using two methods. First, I use numerical modeling to simulate the subglacial hydrology. So that's basically, once the water reaches the bed, then there are these channels that form that drain the water. But it's not so straightforward that it just drains. When you get a lot of water, you're going to get higher pressure, which can actually lift the ice up and cause an acceleration. The ice slides faster. But then that frictional heat that's generated from the sliding helps melt out bigger channels. When you have bigger channels, the water pressure is going to go down and it becomes more efficient drainage. So there are all these feedbacks that are constantly interacting, and that's what we're really trying to understand, is how to explain some of the very interesting seasonal velocity patterns that are seen around Greenland. Now the other way I'm looking at this problem has more to do with the surface. So obviously what happens at the bed depends on how much water actually gets to the bed. Now some of the surface meltwater goes directly to the bed via moulins, or these vertical shafts through the ice. Some might just flow across the surface of the ice, and then some of it infiltrates into the snow and into the firn, which is partly compacted snow, and actually refreezes and doesn't drain off the ice sheet. So it's a big question, is how much water could just refreeze in different areas and how much is making it to the bed and draining. To look at this, I'm headed up to the Greenland ice sheet this spring and I'll be measuring permeability of firn. Firn is partly compacted snow. As snow gradually compacts through the years, it becomes more and more dense and eventually turns into ice. So that intermediate stage is called firn, and that's what we're really interested in, is the water storage capacity of that firn.